Okay, recording has started, just so everyone's aware. If anyone objects, please let me know, but everyone has been informed. Can I
Okay.
make the screen bigger? That's going to be a Discord thing. You should be able to click on the my screen share, and is there a full screen option? That's a good
Yeah, all
question.
you have
There
to
is,
do
yeah.
is just click on Joshua L, and it will go full screen and get rid of all, put all the other speakers at the bottom of the page.
Yeah, looks like I said, if you click on it, it goes through like three phases of being larger and then larger still. So if you just click on the screen share a couple times, it should go full screen as long as your Discord window is also full screen.
Yep.
So hopefully that helps. Um, anyway, so we talked a little bit about at the last community hour last year. Paul introduced us to a puzzle game that we were all playing on the web, and there was some requests to learn how to do a similar game inside of Sinespace because obviously that's more fun than sending everyone out to a web page, which is kind of boring and simple. So we dug up this puzzle gen extension for Blender, which Simon kindly got working for us. It was apparently a little bit of a trial because it only works on some older versions of Blender, and even these 2.9 versions weren't working correctly. So I think he had to go back to 2.8 to get this to work correctly. But we have some puzzles now. So if we go to our Unity here, we're running Unity 2020 with the 2020 editor pack, of course. So we've got, yeah, 2.79 Blender. I've moved away from that, but I think I have both, I think 2.9 and 3.1 or something installed at the moment for when I want to play around in Blender. But um, if we look at Puzzle Gen here, this is this subfolder. There's not really anything else in this project. I started a new project just for Friday calls like this, so we'll work on the puzzle game. And so all we've got in here is the editor pack and the puzzle game folder, which underneath we have the puzzle generated objects that Simon made for us. So we're just going to grab one of those and drag it into the scene. And so if we press F, we can zoom in on it, and we can kind of see that this is a puzzle. Um, the nice part about this puzzle is that while the lines are a bit wonky, it is more or less a grid. So that will actually make it a lot easier to code for when we get to the point of deciding what pieces connect to other pieces. Then the fact that they're in a grid will make our life a lot simpler because we know that the pieces always connect in the four sort of cardinal directions. So we've got that. Let's have a little bit of a look at this and see what we have inside here. So the first thing I'm going to do is I'm just going to unpack this prefab because we're going to be doing all sorts of shenanigans with this. So I'm just going to unpack that. So we've got puzzle. And then let's look at the pieces in here. In order for these pieces to programmatically make sense, we need to make sure that they're in some kind of useful order. So the first piece is there and the second piece is there, which is kind of weird, but all the pieces after that are in the correct order. You can see that they're all in sequential order from row to row, except that very first piece for some reason. I don't know why it ended up that way, but we can fix that. We're just going to move this all the way down to the very bottom here and put that at the end where it's supposed to be. All right, so now that piece falls right in line with the others. Some weird quirk of the puzzle gen script that we're using. So we've got our puzzle, and there's not a whole lot that we need to do to prepare this. We want to put like a picture on here, right? So we can kind of see what we're doing. So if we look at these each have two materials on them. They've got a puzzle top and a puzzle bottom, which is the bottom is basically everything that isn't the actual image that you're assembling. So that actually includes like the little lines between them. Because if we look in here, we can see that there are gaps between each of the puzzle pieces, as you'd expect, to kind of visually differentiate those pieces apart. So what we're just going to do is we're just going to select all of our puzzle pieces under here, and that lets us change the materials on all of them at the same time. I've already got some materials here that I made, puzzle back. That doesn't really make any visual change, but then if we drop puzzle image on top, then we get a nice full image here that's automatically spread across the whole puzzle. And that can be any image that we want to, but this is an image that Simon helpfully provided of some beautiful coastline near where he lives. So that's fantastic. We're going to we can adjust the background a little bit if we want to. So we can click on backing material, and we can decide like, okay, we want those in between spaces to be a little bit darker. You can even make them fun colors if you wanted to kind of help it stand out, something that matched with the image. Like for example, if we can make this blue to kind of blend it in, or we can have some other wild color. But right now we're just going to kind of make it a mid-gray, so that we just have, if we look at the bottom of it will be that same mid-gray. And we probably don't want so much shiny metallic on it. We'll just make it a nice matte color. All right, so we have our basic puzzle. Oh, hi. We've got some new people joining. Mimi, Void, hi. If anybody wants to chat, feel free to just ask and we'll give you speaker permissions. Otherwise, you can just listen if you want to. We are recording, just so everyone's aware. All right, so we've got our puzzle and we've got an image on it. And now I'm going to show you a handy little trick here that's not Sinespace specific, but it can be very useful to know how to do this. It does require a little bit of C# coding, but let me explain the purpose of it first. And hi, Al. Yeah, we can make some puzzle templates available, but if you want to make your own puzzles, then yeah, you'd have to find that plugin or an equivalent version of it. I think it was like $10. But there's probably some free ones out there as well. That just happened to be the first one we found, and while it did the job, we don't actually recommend it because, like I said, it doesn't work well with newer versions of Blender. So up to you whether you want to play with that particular one. Okay, so let's look at our object structure here and kind of think ahead a little bit about what we need this puzzle to look like. So first thing is, like, all of these objects, the names of them are fine, I guess. They're a little bit awkward. They're just kind of auto-generated puzzle dot number. This last one that we had to fix, like, we could manually fix that if we want to, make that puzzle 192. So there's 192 pieces in this puzzle. But one thing that's going to be useful to us later is these puzzle pieces actually being inside of a container of some kind. So right now, these are just standalone puzzle pieces, right? I can pick these puzzle pieces up. But to do some interesting special effects with them later, it would actually be more useful if they were inside of a container and we were moving the container around rather than the piece. So that would be kind of tedious to do here because we would have to say, create a new empty, right? This is puzzle piece 192, reparent this to it, right? And that's tedious, and it's tedious for a couple reasons. One is, like, we want to make sure it's in the same spot. By default, that object gets in the center of the object, so we'd actually have to copy the transform of the piece that we were interested in, move it where it's at, then copy that over here, and now we have a container that has the puzzle piece inside of it, and we can put other things now in that container with it. And if we move the container around, we're not just moving the piece around, but we're moving other things around that belong to it as well. But I'd have to do that 192 times. So new object, rename it, copy the transform, reparent it, move on to the next one. That would be super tedious to do 192 times. So I'm going to undo that, actually. Get rid of that. And let's look at an easier way to do that. So in Sinespace, we don't allow you to upload C# code to the world, but there's nothing that says that you can't. Yeah, imagine if you have a 1,000-piece puzzle, you'd be at that for days just manually moving those things around. So yeah, we don't let you upload C# code to Sinespace, but there's nothing that stops you from using C# code in the editor. You can actually write your own sort of tools and extensions that go along with this and use them to your heart's content in the editor before you upload it. And so one of the things that I've done here is if I come to this tools menu, I wrote a couple of extensions that this tools menu um, it displays. That's why you may not see a tools menu on yours because you don't have any extensions that want that menu, but here it is. And so this one's actually one I had for different purpose before. It's just a bulk child renamer. So I can just drag in like puzzle, for example, and then I can say rename all of the children to puzzle piece, and I just click rename, and it just sequentially renames all of the childs of that object to whatever I asked it for. I originally made this because I didn't want to manually rename 500 seats in in a region. So I could make this seat and rename, and all of those automatically sort themselves out because seats have to be uniquely named or they don't work right in Sinespace. So that was that. I didn't want to again manually intervene on hundreds and hundreds of objects, and so this is a handy way to do that. But it doesn't do good.
Josh, just as an aside add-on to that, there is also an asset on the Unity Asset Store completely free. I think it's actually called Bulk Renamer, that actually has a method of doing what you're asking as well. So rather than anybody having to write their own C#, they can grab hold of that asset and that will rename multiple objects as well.
Yeah, that's great. That particular script doesn't do exactly everything that I wanted to do, so actually I made a new one called prepare a puzzle. And if I drag this puzzle object in here and just say go, then what happens is not only does it rename everything, it actually takes all the original pieces, puts them inside of a container called puzzle piece 1, 2, and 3, and then moves the original mesh object in there and just renames it to piece. So all of these just have a piece underneath them. And so that all just happened automatically just by dragging the original puzzle in here. And that's useful because you have to think about it not just in terms of we're making this one puzzle, but we may want to make many puzzles of different sizes and different complexities. And I don't want to have to, not only would it be tedious to manually prepare this one puzzle, but I don't want to manually prepare a bunch of different puzzles. So if we look at that puzzle preparer, it's actually not a very complicated script. It's only like 60 lines of C#, and most of that is just sort of template stuff. In fact, you don't actually need even most of these, but it's just basically, I'm not going to do a whole thing on creating editor windows right now, but it's worth knowing that it's something that you can look at. This just has a new class called Puzzle Preparer. It's type editor window. And this is what allows it to be called up from the tools menu. And then this is what makes the window actually look like something. This just has some text on here. There's some formatting, font size, things like that. This is what allows you to drag and drop an object into the hierarchy. And then if I click, this is what makes a button. And this is what happens when I click the button. It first makes sure that I didn't leave this blank. And then if I didn't, it just calls this function down here. And that just goes through all of the children of the object that I have selected, makes a new container, gives that container a name, parents it back to the original puzzle, puts it in the same position as the original piece was, renames the original piece to just piece, and then moves that original piece to be inside the new container, and then makes sure that it's centered within that new container. And so just, basically these like 10 lines of code result in this handy little tool that means I can just go click and a puzzle is prepared for me. And I can expand that as needed to make the puzzle more complex later if we need additional functionality on it. So it's just kind of worth knowing that you can do that and save yourself a lot of hassle with, especially preparing imported content that may not be in the right format that you expect it to be. So I won't. If you want, we can have a whole call at some point about making editor tools, but that's just kind of a brief look at that. So we've got that. Now we kind of need to think about most of the rest of what goes on here is going to be code and VFX, right? We have the puzzle. That's pretty much the bulk of it. And so we need to think about, all right, well, what's the code look like? Well, the most basic part of that code is going to be the ability to move these pieces around, right? So when somebody starts a new puzzle, we are going to want to randomize this, like take it apart and scatter the pieces around, and then people need to be able to drag those pieces around and put them back together, right? So let's start by just kind of figuring out the dragging part. Dragging objects in Unity is actually not very difficult. So let's just make ourselves a little test object and we can experiment with. So I'm just going to create an empty sphere here, right? It's just here for us to play around with. Now what I'm going to do is I'm just going to add a scripting runtime to it. Got to have that. And I've got a drag example script here that I made earlier. I made a couple of scripts, but they're all empty. I just didn't want to go through the actual creation process on video here. So we have that object. We've got a script attached to it. And if we go over to here, drag example script, we can see that there's actually nothing in here. The files just got pre-made. So what do we need to do to be able to drag an object around? Well, the first thing we're going to want is like, what are we dragging around? We're going to be dragging ourself around, so we kind of need a reference to ourself. And we have one built in, but it's kind of cumbersome. So I usually make a simplified version of it. So for the rest of the script, I can just refer to my object in order to reference the object that I'm currently attached to, right? So there's a couple different ways to do this in Unity proper and C#, but here's a simple way to do it in Lua that kind of ties into some of the stuff that we've talked about before. So what I'm going to do is I'm going to make an onUpdate function, and then that means I need to bind that to the object's onUpdate event. So just creating that doesn't do anything. I have to come in here and say my object for your onUpdate event, call my onUpdate function. And so got our init function, we call our init function, that assigns our onUpdate function, and now this will actually do something useful. And what is that useful? Well, we need to be able to detect when the mouse is over top of the object that we want to drag, and we need to detect whether dragging is happening or not. So dragging is happening when the mouse is over the top of our object and we're holding the mouse button down, and then when we release the mouse button, we should stop dragging, right? So right off the bat, that tells us, well, we're going to need a variable that indicates whether we're dragging or not. That's going to be a necessity. And then we say, okay, well, how are we going to get how are we going to know whether we're on top of an object, whether we're dragging the thing we want to drag? So first of all, we'll say if we're not currently dragging something, right, and space.input get mouse down, and 0 is left mouse button, right? 1 would be right mouse button, and 2 is middle mouse button, but we want the left mouse button. So, all right, we're not currently dragging anything, and the user just clicked the left mouse button. So we need to decide if that's important to us. And we can see that if we put down, just thing here, left mouse clicked, we'll see that on the console whenever this event happens. So how do we find out whether they're over an object that we care about, specifically ourselves. Well, what we're going to do is we're going to create a new variable, and we'll call it clickRay. And there's some handy functions that are on our camera class, wrong one, over here. So we have, where is it? It's under scene, camera manager, right? We've got some handy functions that are on here. These functions exist within Unity directly as well, although they're obviously in a different place than where our API puts them. We have them on space.camera. On Unity, I think it's actually on the camera object itself. It would be on the main camera, but we have these handy shortcuts to it. So we've got a couple of things here. We've got screen coordinates to Ray, and we're also going to need screen coordinates to world and world coordinates to screen here as we go along. But these three basically are what makes dragging possible, you know, on an object in Unity. So what we're going to start off with is this screen coordinates to Ray here, which just takes a set of screen coordinates. So we're going to be, and that is space dot camera dot screen coordinates to Ray. It needs a set of screen coordinates, but that's real easy to get. So we can do space dot input dot mouse position, which is the coordinates of where our mouse cursor currently is on the screen. So we're just taking wherever our mouse currently is, and then we are creating a ray that goes from where our cursor is on screen and just shoots it straight out into the world under the cursor. Al, are you asking for the link to the reference documents? Is that what you're asking for? These are, here, I'll just paste them in here. There's one for the client, and there's one for server scripting. So yeah, those are just auto-generated reference documents from they're generated by Doxygen, which is just a sort of industry standard program. It just looks through all of our code, finds all the publicly available functions, and any comments that are associated with those, and automatically generates this web page of documentation just straight out of the code, so we don't have to do anything. I would also point out that the what is it? Docs.sign.space. If you don't have that bookmarked, you should. Hamed especially has done a lot of work on documenting the SDK here, and that includes a lot of like useful examples and talking about what all the components do and that sort of thing. So well worth, because there's a section here about all of the components. So it's well worth having a link to that. Like, you know, if I click on seats here, then there's an overview of how to add seats, and that's probably an older image, but this is still a work in progress. But this is all manual work versus Doxygen, which just automatically gives you a list of all of the functions, but may not have great detail about them or very detailed examples of how to use them. And so docs.sign.space can be a better resource for that. So just keep that in mind. So yeah, if we go back here to our script, so this generates, this isn't actually a raycast. This generates the info for us to make a raycast, which we've done on some calls before, where we can beam out a ray, and if it hits something, it'll tell us, right? So what we can do now is we can take that information, now that we've figured out what the ray looks like. The ray starts where our cursor is and shoots out in the direction of the camera so that we can see if there's anything underneath that mouse cursor. It's not exactly in the direction of the camera, but that's because if the mouse cursor, it would only be exactly in the direction of the camera if the mouse cursor was exactly in the middle of the screen. As you move your cursor off to one side or the other, then that ray, that line that points from the cursor to the world, is going to have an angle with it as it moves around the screen. So what we're going to do then is we're going to make an actual raycast, and we'll call it hit, right? Click ray hit, whatever we may or may not encounter as a result of that. And this is just using a standard physics, I think it's raycast single, right? And raycast, if we look at our documentation, it wants, that's under physics, raycast single, it wants an origin, a place to start, and a normal, which is a direction. It's a direction vector. Which way am I traveling, and how far should I travel before I give up, and either hit something, or if I reach that distance, it's a kind of a maximum distance. Then if I don't find anything by then, I just give up and say I can't find anything. And there's an optional layer mask, but we won't bother with that right now. So we need an origin. Well, we handily have that. It's clickray.origin. That's what this function did for us. And it needs a direction, which we also handily have. That's clickray.direction. And then we just have to decide how far it's supposed to go. We're just going to say 100 meters right now, just to stick a number in there. You could be pretty far from the puzzle and still drag the pieces around at 100 meters. So, maybe we decide that's too much, and maybe 50 meters is enough. We can play with that number later. So that sends us out a raycast, and that's going to tell us whether there's anything under the mouse, and if there is something under the mouse, what is it? So how do we do that? Well, this sends us back a raycast hit instead of just a ray, and we can do things like click ray hit dot contains hit, right? So if that actually hit something, if it reached its maximum distance and didn't find anything, contains hit would be false. So we know it hit something, but did it hit something we care about? That's really what we're after. And we can do, all right, so if it contained a hit, and that the thing that it hit, which is clickray.object, is me, then I care about it. They clicked on me. And so if they clicked on me, then we know that their mouse is currently being held down, like the mouse is down. They clicked, and they're clicking and holding, and there was and we were underneath their mouse when they started clicking and holding. So this is, okay, we're dragging now then. But now we need to deal with what happens if they let go. So we're going to come over here. We're going to say else if we're currently dragging, but we get a mouse up event on the left mouse button. So that means they let go of the mouse button. Then dragging needs to stop. Dragging. My southern roots are coming out here. All right, put a proper G on that. And so we can do space.log here. They let go, just so we know, right? And then we need one more thing, and that is what happens if so this on update happens every frame. These events only happen on a single frame. When I click and hold down the mouse button, that click down only happens on one frame, and then never again unless I release and click again. And same way with this, when I let go of the mouse, it only happens on one time. I'll get a mouse up event on just one time. I let go of the mouse, and then that never happens again unless I click and let go again. So that leaves us all the space in between. We've got on one frame the mouse button went down, and on one frame the mouse button went up, but what happens on all the frames in between? That's where the actual movement is going to occur, and we need something to handle that. So right here, we're just going to add a final thing. It says if dragging's down, if we get down to here, then neither of these could be true, because if either of these will be true, if we got a mouse down event or a mouse up event, these would have happened first. So if we get down here, that means dragging's true, but there's been no new mouse events that we have to deal with. So the real action happens here, right? They're done dragging, right? So that's what we've got here is kind of our basic infrastructure. Now, that's all just user interface stuff, like determining whether we should be dragging or we shouldn't be dragging. It's not actually doing anything. If we go back to our thing here, save our scene, play this. Unity crashes on me. That's helpful. That's why I saved right before, because you never know when Unity is just going to decide that it's done. So let's get that restarted. And while it's restarting, let's make ourselves a couple of handy new functions. Unity started up on the wrong monitor. Way to go, Unity. You've never been on that monitor in your life, but today is the day. All right, let's see if we can play this. Yep, apparently that's what my avatar is on the preview grid. So we come over here to our object, and let's clear our console here. So I'm getting some events. You can see in the console that I'm getting left mouse clicked. So every time I click a mouse, you can see this number here goes up. That's great. That means we are detecting. We're not currently dragging, and we're getting a mouse event. But we don't have anything that detects whether we're clicking on the right object. So let's go ahead and add a space.log. They grabbed me. Right, so we can see whether we're clicking on the right object or not. So let's play that again. And all right, so now if we clear out our console, we see we're getting left mouse click events, but we're not getting anything else. However, if I click on top of this, I actually get two events, or three events really. I'm getting left mouse click still, but then I'm also getting they grabbed me and they let me go because I just did a click and release, click and release. So it got both the click down and the click up. If I clear this again and click and hold, I'm only getting two events on my console. Left mouse click was detected. Cool. Then we checked whether it was the left mouse click that we care about, and it was, and we got the they grabbed me event. Now, this doesn't do anything. If I move my cursor around, we haven't actually implemented drag, but we've detected that we've clicked it on the correct object, and I let go of my mouse, and it detects that my mouse is no longer being held down. So now we need to implement the part where this actually moves around. All right, so to do that, we're just going to make ourselves a couple of new functions, right? We're going to call this one drag started. And then we're going to make a function called dragging. Drag started, what do we need to do? Okay, so basically for drag started, our goal is going to be, we know where the object started and we know where the mouse cursor started. So whenever the mouse cursor diverges from its starting point, then the object needs to diverge from its starting point by the same relative amount. And so that means we need the starting point of both of those things. So what we're going to do here is we actually define ourselves a couple of variables because these variables are going to be needed outside of this function. So let's make object start position, right? And mouse start position, right? We're going to need those. So object start position is easy, right? Object start position is just me, where I am in the world, right? That's super easy. The moment I click down, where am I? We're going to need to know that. Now we need to know about the mouse. And the mouse is a little bit trickier because we know where the mouse is on screen. That's space input dot mouse position, which we found earlier. However, the problem that we're going to run into is that I can click anywhere on this sphere, right? The sphere has a center, and that center is the actual position of that sphere, but I don't have to click the center of it. I might be clicking like right here somewhere, or right here, or right here. And so it's not going to work the way we expect it to if we're only expecting you to click on the center of it. So we actually need to figure out how far off of the center of this object you are in order for it to behave the way that we want it to. So how do we do that? Well, we're going to go back to those functions that we were looking at on camera, right? There's a couple of functions here. One of them is screen coordinates to world, and one of them is world coordinates to screen. So if you take world coordinates to screen and feed it the position of something that's on the screen, then it will give you screen coordinates of where that object is. And screen coordinates are like 0 to 1. It's like 0.0 to 1.0 on vertical and horizontal axes. And you can think of those as percentages, right? So that way you don't have to know the resolution necessarily. It's like, oh, it's 5% away across the screen, and it kind of figures out the rest. So we're just going to come over here and we're going to say space.camera.world coordinates to screen, and we're just going to feed it in the position of our object, right? So this is taking where my mouse is and getting the offset of that mouse from where the object actually is on my screen. And that's all we're doing on start, is just storing some useful information that we need for later. The real fun actually happens down here in dragging, where we're now making use of that information that's available. But that's not that difficult. So to actually move this around, how do we move objects around? Well, we just changed their world position, right? So we're going to say my object.world position, and now we need to translate the mouse back into a world position. So we're going to go back the other way. We used world coordinates to screen here, and we're going to use space camera dot screen coordinates to world instead. And what are we sending in there? Well, we're sending in there whatever our current mouse position is minus where our mouse started. So this isn't this is the difference between where we started and where we are now, how much we've moved since we started dragging our mouse around. And that's kind of it. There's some optimization we can do here, and there's some other changes that we can do here. One thing that's like an optimization thing here in update, making these two new variables every single frame can be expensive. So something we might want to do is turn those into variables that we can reuse, right? So we might click for a hit here, and that way we can drop the local from here, and it'll just be reusing that same sort of memory allocation space over and over again. We can do a little optimization work on that. But otherwise, I mean, this should work. So let's just have a look and see how that goes. If we come over here, we play this. If I didn't typo anything. Something's not quite working, right? Oh, you know what I forgot to do? I forgot to actually call those functions. So when dragging starts, we need to call drag started. And while dragging is currently happening, and I also see that I made a bad typo here, which is actually I accidentally named a function and a variable the same thing. So we're going to just rename this to do dragging. All right, so we actually called those. So whenever we detect that they've actually clicked on us, we set dragging to true, and we call our drag started event. So we get our sort of preliminary information, and then we don't do anything else with that for that frame. And then on the next frame, that's in the wrong spot. Move you down here. All right, and then the next frame, dragging will be true, so it will just call do dragging for every frame where dragging is true. And as soon as dragging stops being true, this would no longer get called, which is what happens here. As soon as I let go of my mouse, dragging becomes false, which means this will never happen again until I decide to click on it. All right, let's see if that works better. Hey, look, I can drag a sphere around. Now, this is interesting. It's not quite the behavior we want from the puzzle. You can tell because, like, if I grab this from an oblique angle and kind of move it around, like it's moving it around relative to my screen, right? So if I'm looking at it from the side, then moving it up and down actually moves it up and down. Whereas if I'm looking at it from like a top-down perspective, moving it up and down on my screen is actually moving it back and forth in the world space. And we don't really want people to be able to like take off with the pieces, and you can even drag them off screen. Like we don't want people to be able to just like, throw these pieces wherever or shove them through the ground. Like that's not a good user experience, right? So we can kind of do a little bit of adding some constraints here. So what we're going to do is over here in our dragging event, we're going to make a new external variable here for the same reason as these. It's just more efficient. And instead of directly putting this into world space, what I'm going to do is I'm going to say drag position equals this, right? That's where we're going to be dragging it to. But one thing I want to do is I never want to change the y-axis, which is the up and down in Unity. So no matter where you think you are going to move this to, always make sure that the y-axis remains the same as where it originally started. And then this is just going to drag position over here. Now we're going to get slightly different behavior out of this if we play this. So we come over here and I can still drag this around, right? So I can still drag it around, but you'll notice that I'm not getting any altitude. It's actually sliding around on its own horizontal plane, right? No matter, like if I come over here and I try to drag it up, like it's not letting me drag it up, that doesn't, or down, that doesn't make any sense. I can't go up and down with it. I can still go side to side with it, right? If I'm viewing it from up here, then I can still move it around wherever I want to on the horizontal plane. But at no point does it let me change the altitude of it. The height of it remains fixed over the board. And so that way we can control the pieces, and you can still operate this from an oblique angle. It's kind of useless to operate it from this angle because you can kind of only go side to side with a little bit and kind of a little bit back and forth, but that's okay because you would never do the puzzle from this angle because you can't see the puzzle, so you would have no way of knowing whether you were placing two pieces together that made sense. The final version of this game will probably want a virtual camera so that when players are playing, it automatically positions their virtual camera onto a direction that makes sense for them to be able to see the board. And so this will work perfectly for us, and we can just kind of drag this around wherever we want to. And of course, the next part will be we got to figure out whether a piece is being dragged someplace that it's supposed to go, right? So this kind of got our basics for getting the game mechanics down, right? We just prototyped the game mechanic for dragging pieces around. That's useful to have, but that may seem like, okay, well, it's a puzzle. A puzzle is about dragging pieces around and putting them in the right spot. And so that must be most of what we need, right? We can move the pieces around, or at least we have a working theory on how to move the pieces around. That must be most of the puzzle, right? It's actually about 2% of this whole puzzle, getting it to work the way that you want it to, especially when you throw in the networking and two people might be fighting over the same puzzle piece. So who gets to move it if two people click on the same piece at the same time? And if I'm moving a piece, everybody else should see that piece moving on their screen as well, when I drop it into place. And then we're gonna have all sorts of extra fun things to worry about when it comes to networking, like if a new user logs into the scene mid-puzzle, we got to catch them up. They've got to be able to, they weren't here to get all of the past information of where pieces were being moved around. And so we have to catch them up to where all the pieces are now. And so that they can see the puzzle as everyone else sees it, even though they just came in halfway through. And then they can carry on from there and get continuous updates. And then there's the working out, like, how do we work out whether a piece is being connected to another piece that's the same kind. And, you know, there's also working out things like, if two pieces are connected, we probably want to drag them together instead of separately, right? So we would have to have a more complex drag for that, saying like, oh, these guys, they're actually connected together. So all the pieces that are connected together, if I click on one of those, it needs to take all the other pieces with it. And so we wouldn't just be moving one object around, we might be moving many puzzle pieces around all at the same time. So how that gets handled, and then we have to have like, okay, well, how does somebody opt into the game? You know, if we're going to put up this camera view over here as kind of the ideal way to play the game, then they have to have some way of saying, oh, I want to play, and it, you know, turns on that camera and gets them set up to play. And then they have to have some way to say like, okay, I'm done playing, I want to leave, and turn all that camera off and extra interface features off and stuff like that, let them go back to whatever else they wanted to do. And so just prototyping the drag around, great start, just only the tip of the iceberg to actually making this a functional game. And we need to think about things like VFX, like dragging a piece around, you know, how does the user know that it's going to snap into position correctly? And so we will probably want to have some indicator of that, which goes to what I was saying earlier about putting these all into individual containers. We can do some fun stuff. We do a little sort of prototyping here. Something we might want to do is we might want to say that all of the pieces that are properly placed would appear as you see them now, right? But a piece that wasn't properly placed, like this one, for example, we're going to run into an issue where, like, okay, if this is just someplace random, then it fights with the board, right? It's kind of intersecting the board, and that looks ugly, and it's going to make it difficult to grab. And so we'll probably want to say that any piece that isn't properly connected, like, sits on top of the board, right? It's a little bit higher than the board, and so all of our unplaced pieces, you know, will be obvious. And then when it gets assigned to a spot, you're like, oh yeah, that's where it goes. It needs to drop down and click into place, right? So that's going to be important. But how do we indicate that to the user? Well, something we might want to do there is, if I do that, if I go over here into this puzzle piece, let's say I make a copy of this piece, and we'll just call it shadow for now. It can be whatever we want it to be. And let's go over here and make ourselves a new material, right? We're just going to make a new material, and we're going to call it puzzle shadow material. And we're going to make this a transparent, and then we're just going to give this like a semi-transparent bright color, right? This would probably realistically be like like an unlit. Do we have a transparent unlit? Yeah, let's use a transparent unlit. That doesn't have a color. Can I get? Yeah, this one doesn't let you do a transparent color. That's just a base color. All right, we'll find a better shader for it later. But for now, we just got ourselves a transparent purple material here. Actually, let's not use purple, because that's like Unity's missing missing image color. Let's go with green. So what I'm going to do is I'm going to put this shadow material onto the duplicate puzzle piece, right? I'm going to put it in both slots. And so normally, if a piece is locked into place, then you would just see the piece as it is. Even if it weren't locked into place, you would still just see the piece as it is. It's just sitting there waiting for somebody to start dragging on it, right? And so what we'll do then is we'll say, actually, it's like this piece might just be like sitting here, right? And then we're like, okay, we need to indicate that this piece is being dragged by somebody, first of all. And then we need to indicate whether it's being dragged someplace useful. And so we can just do something simple where we say like, okay, when dragging starts, what we're going to do is we're going to lift this piece up a little bit. And that indicates that somebody's actually moving it around. And then we're also going to turn on its shadow object underneath it, which isn't actually transparent. There we go. We'll just kind of make it a little transparent. Right? So when you're dragging a piece around, it would look like this. You're actually like, it pops up off the board, but it has a shadow piece indicating where it is. And we can make it snap, right? So like we could do this thing where if you get like close to where it thinks this piece is supposed to be, then what we can do is we can make this shadow piece automatically snap into place. And so that way, even if you're not exactly hovering exactly pixel precision on where that piece is supposed to go, if you get reasonably close, then the game's going to go, yeah, that fits here. And you can tell because this shadow piece is snapped into position. Even if you were to like move this around a little bit, you would see that that shadow piece remains snapped into position. And that way you know that if I let go now, this piece is going to fit perfectly into that puzzle. It's where it's supposed to go. It just snaps into place. And so that's what we're going to try and achieve programmatically here. And that's what I was mentioning earlier, why it would be useful to have these objects inside of a container that wasn't just the object, because I can move the whole container around, or I can move the pieces around individually and do different things with them. So these guys, you know, in that scenario, as soon as you let go, these guys would snap the whole piece back into place, right? The shadow would go away, this piece would drop down into where it's supposed to be, and it's now locked into place. And we would record in the code that that piece is now locked into place alongside other pieces. And once all the pieces have been recorded as being locked into place, the puzzle's done. And then we can present the users with an option to be like, oh, that was fun, do it again. And it re-randomizes all the pieces and scatters them around. You could even give them the option of, you know, changing the image, pick a different image to put together the next time, or keep using that image and, you know, it scatters itself around again. And it'll be different because the pieces aren't where they were before. Hopefully that answered your question, Al, about the pieces, making sure they're correct. That little snap won't happen if it's not in a place where it would connect to the pieces around it. And so that's, you can see that like there's a lot to do here aside from just making this draggable. That's kind of like, okay, we solved dragging, but we haven't solved networking the dragging. We haven't solved pieces knowing where they belong and who they're supposed to connect with. We haven't solved who's playing and letting them come and go. There's a lot of sort of other gameplay wrapping elements that need to go around that in order for that to happen. So let's talk a little bit. Well, first of all, let's revisit our tool over here, our puzzle making tool, just very briefly, because you can see that like, okay, if I need a shadow for every piece, I don't want to have to come in here and manually make 192 shadows on all of these. So actually I can just update the puzzle prepare tool and just say re-prepare this puzzle, and it will not only make a container and shove the piece inside of there, but then also make a duplicate of that piece with you know, with a different name, but it's still the same mesh object, and that just saves me from that hassle. So we'll do that when we get to that sort of UI point with it. But that's like how we can see we can evolve that puzzle preparing script as our puzzle gets more complex, we decide, oh, we have more needs for it, we can continually adding on to that. But let's have a little think about the networking side of this, which is kind of going to be, that doesn't have to be the next thing we tackle, but it's going to have to be tackled one point or the other. I've set this up. I made a blank server script to put this in because a server script makes the most sense for this. And the reason it makes the most sense for this is kind of the issues that we mentioned earlier. You could do this with just peer-to-peer networking where there was no server script and it was just the puzzle on my computer talking to the puzzles on your computer. And that can work, but we're going to get into fights about it, right? So if I click on a piece and you click on a piece at the same time, both of our computers think that nobody is currently touching that piece because that's the information we have right now. And since we both think nobody's touching it, we both think it's okay for us to touch it. So we're both going to claim ownership of it at the same time. And depending on latency, like your latency versus my latency, then, it could be a couple tenths of a second or something there where, there's nobody really knows, you don't know yet that I've clicked on it and I don't know yet that you've clicked on it. And then suddenly we both get told, oh, the other guy's clicking on it. And I'm like, no, wait, but I'm clicking on it. And that dispute has to be resolved. And that gets worse the more people who are in the scene, because depending on their latencies, if there's 20 people in the scene, maybe half of them get my message first and half of them get your message first. And so now they're all confused about who's actually in charge of moving that piece around. And so that would have to be negotiated somehow. And that can be very difficult and confusing to figure out, like, well, okay, do I say, okay, never mind, you got this? Or do they say that and give up control of it? Neither side knows what decision the other side is going to make. So if I say, oh, sorry, my bad, you can have it, and the other side goes, oh, sorry, my bad, you can have it, you have it, then now nobody's controlling it because they don't, with the latency issue again, like there's no way for, like I could say like, oh, well, wait a second and see if the other guy lets go or something. But it just turns into a whole back and forth mess of deciding who really has control over it and who doesn't. And then you have the extra issue of the new user joining the scene. And if the new user joins the scene, they have to be caught up. But then how do you catch them up? Who tells them what the current state of the game is, right? So they would just have to like pick somebody in the scene at random and say, I think you were here before me. Tell me what the game looks like, and hope that user, the information that user's computer has is correct, and they give that information to you, and then you set yourself up based on what some random user in the scene thinks the board is supposed to look like, which is hopefully correct. But given all of the stuff that we were talking about with like disputes over who's moving pieces where, maybe everybody's seeing a slightly different version of the puzzle. So this turns into a huge mess, which means whenever you're dealing with something like this, it's really good to have a central authority, right? So you want to move from like a peer-to-peer model to like a server client model on the networking, where the server has absolute authority over the game. The server is the one who says, I know where all the pieces are, and if anyone disagrees, that's too bad, because the pieces are where I say they are, and there's no dispute. It's like, I record where they're supposed to be, I tell everybody where they're supposed to be, and everybody just accepts that and plays the game. The pieces on their screen will appear where the server says. And that also lets the server be the authority about who is moving the pieces around, because while there's still latency, there's no crosstalk. So if two of us click on the same piece at the same time, rather than us just going, well, I don't think anybody's using this, so I'm going to claim it. Instead, we go, hey, server, I want to move this. Can I move this? Am I allowed to move this? And the server says yes or no before you can move that piece around. And that way, if two people click on it simultaneously, the server is going to get two messages come in, and whichever message arrives first, the server is going to be like, oh, well, player one, it's your piece. And then just a fraction of a second later, player two's message arrives and says, can I use this? And the server's like, oh, no, sorry, player one got here first. You can't have it. And so that way you avoid having any conflict about who is moving a piece and who's in charge of that piece, because the server is keeping track. Well, this piece is currently being moved by player one, and this piece is currently being moved by player three. And until they let it go, then I'm just going to ignore anybody else's request to move that piece, because whoever picked it up first, they get to play with it until they're done with it and put it down, and then somebody else can pick it up. So I went ahead and made a server script here because that's really the only practical way to do the networking. You can do it peer-to-peer, but it turns into a whole big confusing mess, and there's no reason to, because we have an easy simple solution for that, and that's just to make the server do all of the negotiating on everyone's behalf. And then when somebody new joins the scene, the server already knows where everything is. They don't have to ask another player. The server just goes, hey, new guy, here's where all the pieces currently are, and here's the pieces that are currently being moved by these players. So you're caught up now. Make your board look like this, and you are immediately caught up with what everyone else is doing. So server scripts we've talked about a bit before on past calls. I don't remember whether they were Discord calls or previous calls, but we will kind of work our way through that. But even before we get to that, we need to also think about how we're going to do the dragging of 192 pieces. We can drag one sphere around right now, but that's just one sphere. And that one sphere has a script on it, right, that does the dragging. And that's great for a proof of concept, kind of prototype out, make sure the behavior does what we want it to do. But we don't want 192 scripts on our puzzle, right? If we copied this drag script to every single piece of this puzzle, we'd have 192 scripts that have to start up every time somebody enters a scene with one of these puzzle games. Heaven forbid you have 2 or 3 puzzle games in the scene, then you've got hundreds and hundreds of scripts that all have to start up simultaneously, and not only start up simultaneously, but know that not only are they started up, but all of their other puzzle pieces have also started up. And then we'd also still need like a main controller script to start up. So that would be a massive lag spike for the user right when they enter the scene. Just hundreds of scripts coming online, and each one does one thing, drags that one puzzle piece around. So that's really inefficient. Could be done that way, but really sort of bad design of the programming around this. So we want to imagine a slightly more complicated version of this script where we can have one script that handles dragging the pieces around. And that makes sense when you think about it, because you as an individual user are never going to be dragging more than one piece around at a time, right? Like you're never going to be picking up and moving 2, 3, 4, 10 pieces all at the same time and trying to fit them into the puzzle all at the same time with the same mouse cursor, because they have to be dragged in different directions. And how would you select the 10 and then how would you move them? It just doesn't really make any sense. You as a user are going to pick up one piece and place it, and then you're going to pick up another piece and place it. And so we don't need 192 scripts that have the capability of moving 192 pieces simultaneously. We need one script that can move one piece at a time. The only real difference is that you need to be able to pick and choose which piece you're moving around, rather than always moving around the piece that the script is attached to, right? That's the only actual difference here. So what we're just going to do is we're going to go over to our puzzle. Actually, we're just going to make a brand new object, and we're going to call it a spectacular puzzle game. And then we are going to add a object here, and we'll just call it puzzle script. And then we're going to move our puzzle object underneath here. So we've got our puzzle script. We're just going to add a scripting runtime to this, right? This is going to be main puzzle script, which again is just an empty file that I pre-made, so I wouldn't have to manually make it. Then we're going to add object reference here, right? We're going to just say the actual puzzle object is over here, so that the script knows how to find this object that is the actual physical pieces. So we've got that. We're going to save that. We're going to move our sphere kind of out of our way here. Yeah, that's probably not where that should be. We're just going to, the coordinates of this are off, so I'm just going to center my object here before I drag this puzzle in. All right. So we've got that. Save the scene just in case Unity decides to crash on us again. And so now we need to think about how this puzzle, how our drag script can be adapted to move any piece rather than just this one sphere. And we're not going to have time to get through all of this in the next 20 minutes or so, but we can kind of get started on it, right? So this is going to be a multi-week thing. It's going to be way too complicated to do it all at once. All right, so we know we have a reference to the actual puzzle object, so that's useful. The other thing that we need to know about this puzzle is how big it is, right? If we're going to treat this as a grid, right now, these puzzle pieces are all just side-by-side children, right? They're all in a list. And so we need to know, in order to treat this properly in the code, we need to know the X and Y dimensions of this puzzle. And the dimensions aren't the actual size of it, it's the number of pieces, right? So if we count these up, we can see that this has 12 pieces per row, all right? That's really all we need to know. We can figure out the other side. We just need to know that every row has 12 pieces on it, or column in this case. So we can just start with that. We can just say puzzle size is 12, right? Well, we'll work with that. Then we're going to need a big fancy array. We're going to make a big array called puzzle info. And it's going to start empty because we're going to have to fill it up ourselves dynamically. We've got to figure out all of the information that's going to go into this. We're going to make ourselves an init function. When the script initializes, the first thing we do is call the init function. And if anybody's wondering why that happens, why I usually do that in a script, that's because scripts that are not compiled programs, if it's a scripting language like Lua, it doesn't work like a normal program does, where it evaluates the entire program at once, make sure it's all correct, make sure it knows what everything is, and then runs it. That's how a normal compiled program works. In a scripting language, it actually just takes this line by line. It says line 2, run that, do it, whatever it is, just do it. Next line, do it, just do it right now. I don't know what comes after that, but we're just going to do this right now. And so you get yourself into a situation where if you start doing functions or touching code that is below you, the code hasn't happened yet. And so we want to make sure that the script is completely loaded, that every line of the script has been looked at once before we start actually running any real code on it. And so that's why at the end, the very last thing I do is I'm saying, like, none of this does anything, right? Like, I'm allocating some memory space, that's fine. That's not dependent on anything else existing. I'm defining a function, that's fine. Anything that happens in this function doesn't matter until the function is actually called. And so that's why the function doesn't actually get called until the very end of the script. And I'm sure that all functions have been loaded, all variables have been initialized, everything's ready to go. And so at the very end, I'm like, there's nothing below me. There's nothing else under this. So go, start, do whatever you're supposed to do. So what are we supposed to do? Well, we have our puzzle, and we kind of need to take that puzzle and store it in our memory so that we have sort of an understanding of what the entire puzzle looks like. And so what we're going to do there is we're going to, first of all, find out how many puzzle pieces we have. So we're going to get the pieces. What are the pieces? Well, the pieces are just the children of the puzzle object, right? And that immediately tells us not only what the pieces are, but how many of them are there are. And so what we're going to do there is we're then going to loop our way through each of those puzzle pieces and kind of do a little bit of mental processing on each of it. So we're going to have ourselves a for loop here, and we're going to say p equals 1 because Lua is 1 based. And how many times are we looping? Well, we're looping for however many pieces there are and incrementing by 1 each time. So that's gonna make us look at every single piece. And then we're gonna say, okay, let's just keep this very simple to start off with. We just want to be able to drag these pieces around. So what we're going to do is we're going to just store a reference to all of these puzzle pieces. And this will have to get a lot more complicated later, but let's see if we can just do the drag part for a moment. We're going to say initialize, and we're going to say like, okay, so then we need to table.insert puzzle info, the pieces. And we're actually going to wrap these in their own little container, and we're going to say container equals the whole thing that they're in, which is great. But if we remember, the container is actually just an empty object, not something the user can click on. So what we actually care about is whether they're clicking on this piece inside the container. So we're getting a reference to the container. And then we need a reference to the piece itself. And for the moment, we're just going to kind of cheat on this and just say that the piece is just going to be the first child of the container, because we know that we can make it more intelligent later, but that's all we've got. So for every piece, we're adding into our array a object reference to the container, which holds a whole bunch of stuff, and the actual visible piece that the user can click on. So we're going to need that. And then we need all of our drag stuff, right? So we're going to grab all of this stuff from our example script, and we're going to shovel it over here into our new main script. We also need to make sure that we're initializing our update function. Right? Okay, so we've got that, and this is, again, most of what we need, but we have to make it pick up an object. We have to make it decide whether it's an object, a particular puzzle piece, and then make it pick up that puzzle piece as rather than the whole board. So what we're going to do is we're going to size our a new function called isIt a puzzle piece, and this takes in some kind of object that we'll call clicked object. And so whenever we want to know whether they are clicking on something important, then what we're going to do is we're going to come in here, and instead of saying, is the object they clicked on me, then we're going to define a, call it clicked piece, is it a puzzle piece? the object that the ray hit. So we're taking whatever object's under the mouse. When I click, I found an object, cool, pass it into our function and tell me if it's a puzzle piece or not. How do we know if it's a puzzle piece or not? Well, we're going to, and we'll make this more intelligent later, but let's just brute force it for now because we're almost out of time. But how do we know if it's a piece? Well, we're going to look at all of our known puzzle pieces, and we're going to say if clicked object is equal to puzzle info piece. And if it is, then we're going to return not the piece, but actually the whole, all the information we have related to that piece. So actually what we're sending back is puzzle info P. We could actually just send back P, but we'll talk about why that's useful later. And if we don't find anything, we're just going to return back nil. It wasn't, whatever you clicked on, it wasn't one of our pieces. And so now we can come up here and we can say, if clicked piece is not nil, then we know that we got something. Instead of saying they grabbed me, I'm going to say they grabbed clicked piece dot container name, because the name of the piece they clicked on is just piece. To know which actual piece it was, we have to look at its container, which is like puzzle piece 5. And so now dragging is true. The thing is, though, like if we call drag started and we go look at drag started, it's still referencing my object. So that's not great. We need to tell it what object we're actually moving around. So we're going to define a new variable called drag object instead of my object. And so whenever they click on a piece, then we're going to say that drag object equals clicked piece dot container. So we want to move the whole container around, not just the little piece inside of it. Then dragging's true, dragging started, and then up here all we have to do is change my object to drag object, and again down here my object needs to be drag object, and in theory that lets us move the whole puzzle around, assuming I didn't make any mistakes. So let's have a look here. Save this scene just in case. If I play this, let's see what we got here. Can I move these pieces around? Left mouse clicked. Something's not right. It did not, it's not detecting the piece. Let's see. If contains hit, clicked piece must be coming back as null for some reason. So let's see if we can debug this real quickly here. Let's find out what we actually clicked on. Space.log is it a piece? Clicked object dot name. Let's find out if let's see what we're actually clicking on. And then we'll say checking puzzle info p.piece. And this may be an object mismatch, but we'll have a look here and see what we've got. And then just to be, let's see, space.log. Was it a piece? I will just say click piece and see what comes back from that. All right, let's see if we can get a little bit extra info out of this. If I try to move a piece around, left mouse clicked. That's weird. Oh. The script's actually crashing. Execution went on too long during startup. This left mouse click is actually coming from our sphere, which we should turn off. That's why it was throwing me there. So sphere, we don't want that running right now. And it's actually it's actually blowing up trying to do this, which really should be a coroutine to start it up, but we will deal with that later. In the meantime, let's just give it some more execution and see if it works. Something to concatenate a user data. Okay, yeah, this is just the debugging script is messed up. This should be piece.name. Was it a piece? Checking piece. Was it a piece? Okay, so now we're getting somewhere. Now it's at least doing the check to see if it is a piece. And doesn't think that it's a piece, so that's a separate problem. So we're just going to simplify this real quick just for the last couple minutes here. The explanation of why it's confused about that is complicated. So what we're actually going to do is we're just going to actually see if clicked object.global ID is equivalent to piece.global ID rather than doing a direct check on that. Still not working. Is it a, oh, it thinks I'm clicking on the floor. Why is it going through? Is it a piece floor? Why are you clicking on the floor? Apparently do these not have, they don't have colliders on them. That's the problem. There's nothing to click on. All right, let's fix that real quick. Piece, select all of the pieces. All of these guys, and add a mesh collider to all of them. And save. All right. Got to have a collider. You can't click on it. The raycast won't see it if it's not physically there. All right, and we've got another error here. Oh yeah, this is just the debug. Was it a piece? Yeah, we'll just get rid of that. Can't turn an object into a string, as it turns out. All right. Hey, look at that. We pulled a piece out. Can I pull a different piece out? Yeah, I can pull that piece out. That one's over there. Yeah. Okay, so now we can actually grab all the individual pieces and move them around. So this is one script, and it's not really much more complicated than the original one. So we have our drag example script, right? So that's 48 lines. This main script, which moves all the pieces around, it adds a little bit here in order to first catalog the pieces so that it knows where all the pieces are. And then we have a little extra function to match the object that you clicked with one of the pieces that we've previously known about on the board. But everything else is basically the same. Like all of this is pretty much the same as the drag example script. The only difference is instead of using my object, we're using this drag object so that we can change which physical object that we think we're dragging around. So I can grab any of these. And of course, I can put them back, but they don't really snap at the moment. Snapping feature is not there, so I can kind of manually position them back in place if I want, but it's like, it doesn't click, so it's got to be very careful about positioning them. But that we only have one script that manages all the piece movement, and that script will also manage networking. Like whenever I move a piece around, it's going to tell everybody the piece is being moved around, and if somebody else moves a piece, that script is going to make sure that the appropriate piece on my screen is where it should be on everyone else's screen as well. So we'll have to leave it there for now, but we made it far enough to actually be able to drag and move our puzzle pieces around. So that's great. And then the next step, like I said, will be sorting out that networking and getting into server scripts and that sort of thing. Yeah.
Awesome.
Does anybody have any
Yeah, good.
questions about that? I'm just going to check the chat here real quick.
Are we making the project available afterwards? Because Al was
Yeah,
saying
yes,
she
we will.
too complicated.
Yeah, we'll upload it to GitHub when it's done, right? We have
Yep,
a
cool.
GitHub repository, and so there's no reason, this is all stuff that we made. I think even we'll double check, but I'm pretty sure anything we made using Puzzle Gen we can distribute as long as we don't distribute Puzzle Gen itself. So there's nothing that stops us
Yep.
from distributing the actual mesh puzzle pieces. And of course, we wrote the scripts, so we get to decide what happens with those. And I'm happy for this to go up on our GitHub repository when we get done with it.
Cool. Yeah, it's a lot more complicated than I thought it would be.
Yeah, and like I
The
said,
bit I was dreading was knowing how to know where your jigsaw pieces were in the first place for when you randomize them to get them to snap back in. But it was just a scan in the end through the children.
yeah, and that's
recording
something that
their coordinates.
it's something we haven't really gotten to yet, but that is what we will be sort of dealing with next. Is we'll be adding more information to this. Right now, all we're remembering is the objects so that we can figure out what we're supposed to be dragging. But we're actually going to need to store a lot more information. One of the things
coordinates to start with.
Yeah, one of the things exactly that we could remember is the original, I would say local position of that piece, right? And then we're also probably going to want to store a subarray of the pieces that it connects to, right? Since it's a grid, we could imagine that this represents, the four directions that something could connect to. Maybe if it's a corner piece, there's nothing to connect to the left and top, but then we have, a right piece and a bottom piece that we know it connects to. And so we can scan and pre-cache the relationship of all of the pieces that with relationship not only to the entire puzzle but to each other, like, oh, I connect to you and you connect to that guy, and then when you start a new game you can randomly move these pieces around, but you still will know where they originally started, so you can always put them back again. So that some stuff like that is what we would have to get into after we do the sort of networking portion of it. Is okay, we can move the pieces around. We've networked it so everybody, can properly take hold of a piece and know that they're the only one moving that piece, and everyone sees them moving that piece. And then it'll be like, okay, now how do we do the detecting whether two pieces go together or not, and then snapping them together appropriately? Because like you might want to have, in addition to knowing who you should connect to, you're going to want to know whether all of your connections have been established, because that's what determines whether the puzzle is finished, right? Whether all of the possible things that this piece can connect to is actually connected, and that's true of every piece. So yeah, that'll be like the third part of this. The next part of this will probably look at the networking and get that sorted out, and then the third part will be like, okay, actually, how do we make these pieces snap together and decide when the puzzle is finished?
I can see there's so many parts of this that are useful for lots of other things, not just this puzzle game. It's yeah. I mean,
it's a good one. It's very interesting.
You could use the same principle sort of for a building game or a 3D puzzle as such. Yeah,
you could do that. But that's why I was saying, like when we prototyped moving the sphere around, that was just a tiny part of it. So yeah, I mean, it's a useful and important part of it, but it is just a tiny part of it. And now we can move all the puzzle pieces around. So but you can see that was only just a little bit more. That was just a tiny step to go to. That's another 20 lines of code to make it move all the pieces around, but we're still only making little incremental progress here.
Yeah.
Yeah.
Okay, I'm going to stop recording then. Thank you everybody for coming.